When plants see phosphorus, in terms of the phosphorus that they can take up and utilize, they see this from the soil solution phase. And the phases that plants can take up that contain phosphorus are called orthophosphate. And this is a little confusing. So sometimes people just say soluble P. And that may be confusing to some people because they don't know what form phosphorus actually is when they say soluble P. So I can tell you that the terms soluble P and ortho P or orthophosphate are relatively interchangeable. So when we talk about orthophosphate are all of the types of forms of PO4, and PO4 is phosphate. So what do I mean by all forms of phosphate? This is what I mean, illustrated on this slide. Orthophosphates range from H2PO4 to H2PO4 to HPO4 and PO4. Right? And you can see that as we move from the right to the left, there's more and more hydrogens, which tells you something. What it tells you is as you move from the right to the left, there's more acidity present, more free hydrogen ions. So way over on the left, H3PO4, this is highly acidic. And this is actually referred to as phosphoric acid. And as we move from the left to the right, the solution that contains these types of orthophosphates becomes more and more basic. So how do I illustrate that to you? I illustrate that to you using these three equations. And this is what happens as you move from something like soil solution or solution in general that's highly acidic, like H3PO4, or this is phosphoric acid. As you move from highly acidic to more basic, the H3PO4, or the three H's, the H, one of the hydrogen ions, is stripped and is removed. And this is potentially neutralized, this free hydrogen ion on the right-hand side of this equation. So now we have H2PO4 minus. And you've learned up to this point that this form of orthophosphate can be taken up by plants. This reaction continues where H2PO4 with a -1 charge can also lose another hydrogen ion if the pH is increased. And now you have HPO4 2- with this free hydrogen ion that's likely neutralized somewhere. HPO4 is also referred to as orthophosphate, just like H2PO4, and HPO4 can be taken up by plants as well. If you continue with the third equation, HPO4 can dissociate to form orthophosphate as PO4 and release a free hydrogen ion that's likely neutralized. Now I can tell you that PO4 and H3PO4 are not taken up by plants. And there's a reason for this. The reason why H3PO4 and PO4 are not taken up by plants is based on pH, as you see in this diagram here. Okay, so this diagram shows you the range in pH from 0 to 14 on the x-axis and the fraction of total orthophosphate on the y-axis. And it goes from 0 to 1, but it can easily go from 0 to 100. And the different colored curves show you the different forms of phosphorus. Let's ignore everything in green, light green colors for now. Okay, so if we start down at pH 0, the orthophosphate that's present is H3PO4. This is phosphoric acid. As you raise the pH and you go from 0 to about 4, maybe 4.5, the H3PO4 is converted from H3PO4 to H2PO4. That's the pink curve. Eventually, all the H3PO4 dissociates and becomes H2PO4. Now, right about pH 5 or so, H2PO4, as you increase pH, is converted from H2PO4 in pink to HPO4 2- in yellow. Right? And if you increase the pH further, HPO42 minus, the yellow curve diminishes, and PO4 becomes the dominant species way out at pH 14. Now, if you look at the two vertical light green lines, I drew those in there on purpose. Why did I draw these in here on purpose? And they're not really set exactly where they should be. They probably should be a little bit closer together, maybe from pH 5.5 to 8.4. Regardless, where do most of our plants like to thrive in terms of the pH scale? They can grow from between about pH 5.5 to 8.5. And if you look at this curve or these sets of curves, what that tells you is that the forms of orthophosphate that are present between those pH values is what's circled in the green circle or oval above. It's H2PO4 and HPO4. And this is why when we talk about plants and uptake of orthophosphate or soluble P, that plants only take up H2PO4 minus 1 or HPO4 2 minus.